Hey there guys, welcome to my walkthrough of the November 2017 Edexcel Higher GCSE Maths paper 2. So it's a calculator paper. Make sure you check out the description for lots of useful links to help with this paper, your revision in general, and also my playlist containing every paper walkthrough up to now. Let's go. Okay, number 1 wants us to solve 5x minus 6 is equal to 3 lots of x minus 1. So, first step, expand the brackets. So we get 5x minus 6 is equal to 3x minus 3. Now we want to get x on its own, so the next thing I'll do is subtract 3x, so we get 2x minus 6 is equal to minus 3, add 6 to both sides, 2x is equal to 3, and then divide by 2 and x is 3 halves, which is 1.5. Okay, number 2. Emily buys a pack of 12 bottles of water. The pack costs £5.64. Emily sells all 12 bottles for 50p each. We want to work out Emily's percentage profit to 1 decimal place. Okay, so to do that, we need to work out the profit that she has made. Profit is money made minus money spent. And then to find that as a percentage profit, we divide the profit by the original cost and then multiply by 100. So she made 12 times 50p, which is 12 times 0.50 pounds. Now that gives us £6. Now her profit is £6 minus 5.64, which gives us 36p or 0.36 pounds. So percentage profit is 0.36 divided by 5.64 times 100, and that will give us to 1 decimal place where we get 6.38 blah blah blah, so that's 6.4%. Okay, number 4. There are only blue cubes, yellow cubes and green cubes in a bag. There are twice as many blue cubes as yellow cubes and 4 times as many green cubes as blue cubes. Anna takes a random cube from the bag. We want to work out the probability that Hannah takes a yellow cube. 3 marks. Okay, so there's quite a few different ways we could go about this. I'm going to use a ratio because I know we all love ratio. So, first of all then we're told there are twice as many blue cubes as yellow cubes. So for that, we can say that blue to yellow is 2 to 1. For every one yellow cube, there's twice as many blue cubes. And then we're told there are 4 times as many green cubes as blue cubes. So for that, we could say green to blue is 4 to 1. So, for every 1 blue cube, there are 4 green cubes. Okay, so what would be really handy here is if we could combine these two ratios into a single ratio, which is what we are going to do. Now the trick to combining ratios, and I have a video on this, it'll be down below, is to make the common part of the ratios the same number. So here our common part is blue. Now in the left hand ratio the blue part is 2. In the right hand ratio the blue part is 1. Now we can turn 1 into 2 by multiplying by 2. So for the right hand ratio we're now going to write that as 8 to 2. So, because now both ratios have 2 blue in them, that's essentially saying that if we have 2 blue cubes, we're going to have 1 yellow cube, and if we have 2 blue cubes, we are going to have 8 yellow cubes. So, we can now stick this all in one ratio, so let's go green to blue to yellow. So, that's 8 to 2 to 1. Okay, so now that we have that ratio, we can work out how many parts the ratio has. 8 add 2 add 1, which is 11. 1 part of the ratio is yellow. So the probability is 1 out of 11. Okay, number 5, we have some transformation fun. So part A wants us to rotate trapezium T 180 degrees about the origin and label the trapezium A. Okay. So, 180 degrees is going to take it from the bottom right quadrant to the top left quadrant. So, somewhere up here. Now, every point on the trapezium is going to be the same distance away from the origin. So, to get from this top left point on the trapezium, we go 2 left and 1 up. So we just do the exact same on the other side. So from the origin, we just go 2 left and 1 up, which is going to be that. And the point down below is 2 left, 2 up. So we just do the same, 2 left, 2 up. And the bottom point, which is kind of down here, is then 5 left and 2 up. So just do the same. So 5 left, 2 up. Puts us there. And then this point here is 4 left and 1 up. So that's going to be there. So in the real thing, use a ruler. So there's our trapezium, and we were told to call him A. So let's just take a look how that looks. So there's our rotation of 180 degrees. Okay, then part B. Wants us to translate trapezium T by the vector -1, -3, and label the new trapezium B. So, vectors, the two numbers of a vector, the top number is the x vector, so -1 is telling us to go 1 left, and then the bottom number is the y vector, so -3 tells us to go 3 down. So, the shape doesn't change at all, it literally just moves. So if we translate one point, we can do the rest easily. So let's go for that point there. So we're going 1 left and 3 down. So 1 left and then 1, 2, 3 down takes us there. So then we just draw the rest of the shape in. So there's the height, and then 2 across. So that is trapezium B. Cool. Okay, number 6, we have some indices fun, so 2 1 markers and 1 2 marker. So we are told p to the power 3 times p to the power x is p to the power 9. Part A, find the value of x. Okay, so my indices playlist is linked down below. So, by the rules of indices, if we multiply p to the 3 by p to the x, we get p to the 3 and x is equal to p to the power of 9. So that means then that the powers have to be equal. So 3 add x is equal to 9. Therefore, x is equal to 6. Okay, then for part B, 7 squared to the power of y is equal to 7 to the power of 10. Find the value of y. Okay, so when powers are separated by a bracket, they multiply together. So 7 squared to the power of y is 7 to the power of 2y. So that's equal to 7 to the power of 10. Therefore, 2y is 10 and y is 5. Cool. Okay, then for part C, 100 to the power of A times 1000 to the power of B can be written in the form 10 to the power of W. We want to show that W is 2A add 3B. Okay, so notice in the form we want it, the base number is 10. So what we need to do is turn 100 to the power of A into 10 to the power of something. So 100 is 10 squared. So we have 10 squared to the power of a. Times. Now 1000 is 10 to the power of 3. So we have 10 to the 3 to the power of b. Now, using the rules of indices, again, powers separated by brackets multiply. So 10 squared to the a is 10 to the 2a. And then 10 to the 3 to the b is 10 to the 3b. And then, by the rules of indices, we now add the powers. So this is 10 to the 2a and 3b. So we were told it was in the form 10 to the w. We've now shown the power is 2a and 3b, which is what we wanted to do. Okay, number 7, so 5 marks. So ABCD is a trapezium, and we want to work out the size of angle CDA. And we want to give our answer to 1 decimal place. Okay, so 5 marks. First of all then, let's work out what we are trying to work out. So, angle CDA is this guy down here. Now then, how are we going to do that? Well, so we have this trapezium, we know the height. So, what we can do, first of all, is draw a vertical line there, which we know is 6 centimeters. So we're going to be a little bit lazy with notation and just write 6. Now, this is a right angle triangle. In right angle triangles, we can find angles if we know 2 sides using SOHCAHTOA. So we either need to find the length of the slant or the bottom of the triangle. Now it's the bottom that we can find. So we know the base of this trapezium altogether is 24, and we know the top is 10. So that means that this length and this length over here add up to 14. So if I call this length over here x, and then I'm going to call this length y, we can then say x add y is equal to 14. So, we need to find then the value of y. So, can we find the value of x? And the answer to that is yes. This over here is a right angle triangle. We know 2 sides, so we can work out the third side using Pythagoras. So we know by Pythagoras that x squared add 6 squared is equal to 7.5 squared. So x squared is, x squared add 36 is equal to 7.5 squared, which is 56.25. Therefore then, x squared is equal to 20.25. Now if we square root that, x is equal to 4.5. Okay, so from that we now know the value of x. So we now know that 4.5 add y is 14. So we then know that y is 9.5. So now that we know that, we can play SOHCAHTOA. So if we call this angle theta, then the bottom is the adjacent, and the 6 is the opposite. So is it so? No. Ka? No. Toa? Yes. So we now know then that tan theta is the opposite over the adjacent, so 6 over 9.5. So theta is the inverse tan of 6 over 9.5. So let's see what we get. So to one decimal place I get 32.3 degrees. Cool. So if you're rusty on your SOHCAHTOA, my playlist is down below. Okay, number 8. Probably the nicest question of them all. So we want to use our calculator to work out the square root of sine 25 add sine 40 all over cos 25 minus cos 40, and write down the whole of your calculator display. So the only thing you need to be really careful here with is when you put the trig in, make sure you close the brackets after the numbers. So for example in the sine 25, your calculator will open the bracket, put in the 25, make sure you then close the bracket. So put it in exactly as I have there, and you will get 2.756 blah blah blah. Okay, then part B wants us to write that correct to 2 decimal places. Okay, so we have 2.756 blah blah blah. So the second decimal is 5, which is followed by a 6. So we round it up 1, so we get 2.76. Okay, number 9, we have proportion. So yesterday it took 5 cleaners 4.5 hours to clean all the rooms in a hotel. There are only 3 cleaners to clean all the rooms in the hotel today. Each cleaner is paid £8.20 per hour, or part of an hour that they work. How much will each cleaner be paid today? Okay, so this is a bit of a bad question. It should say whether or not each cleaner works at the same rate, which, to be able to do this question, we are going to assume. And when it says each cleaner is paid £8.20 for each hour or part of an hour that they work, essentially that means if they work for 3 hours and 5 minutes, they would get 4 times £8.20. Okay, so this is inverse proportion. So if it takes 5 cleaners 4.5 hours, let's first of all work out how long it would take one cleaner. So if we're dividing the number of cleaners by 5, it's going to take them 5 times longer. So one cleaner would take 5 times 4.5 hours. Now that's 22.5. Now from that, we can work out how long it would take 3 cleaners. So we're multiplying the number of cleaners by 3. Which is going to divide the time by 3. So 22.5 divided by 3 is 7.5 hours. So the cleaners are going to work 7.5 hours each, which means then they get paid 8 times £8.20. So that's going to be 64 and 160, £65.60. Okay, number 10. So we have a distance time graph for a car's journey. So going upside, we have distance in meters, and along the bottom, time in seconds. Part A says between which 2 times does the car travel at its greatest speed? Give a reason for your answer. Okay, so on the distance time graph, speed is gradient of the line. The reason being, speed is a rate of change of distance over time. Gradient is a rate of change. So, the steepest part of the graph is between 0 and 20 seconds. And the reason you would put is that the line has its steepest gradient in this time. Okay, then part B wants us to work out this greatest speed. Okay, so the speed, again, is the gradient. Now to work out gradient, we do the difference in y over the difference in time, x, sorry. So difference in y over difference in x. Here for us, that's the difference in distance over the difference in time. So speed is, so at the start we're at 0, 0, and at 20 seconds, well, the scale is such that one big square represents 200 meters, so every little square represents 20 meters. So here we're at 360. So the coordinates are 20 seconds, 360 meters. So our speed then is 360 minus 0 over 20 minus 0, so it's 360 minus 0 over 20 minus 0, which is just 360 divided by 20, which is 36 divided by 2, which is 18 meters per second. Okay, number 11, the pie charts give information about the ages in years of people living in two towns, Adley and Bridgeford. And the question says that the ratio of the number of people living in Adley to the number of people living in Bridgeford is given by the ratio of the areas of the pie charts types. We were asked what proportion of the total number of people living in these two towns live in Adley and are aged 0 to 19. Give your answer correct to 3 significant figures. Okay, so bit of a strange one. So let's start our ratio Adley to Bridgeford. So what we're going to need to do is find the area of each pie chart. So area of a circle is pi r squared. Now, if you had this printed off properly to scale, you would find the radius of this circle is 5 centimeters. So the area then is 25 pi centimeters squared. And if we did the same for Bridgeford, we would find that the radius is 4 centimeters. So the area is 16 pi centimeters squared. So we now know the ratio of their areas is 25 pi to 16 pi. Now we can cancel out the common factor of pi and just write it as 25 to 16. Now altogether, this ratio has 25 add 16 parts, which is 41. 25 parts of those 41 parts live in Hadley. So, 25 41s live in Hadley. Okay, so what we now need to do is work out what proportion of the people living in Hadley are aged 0 to 19. So for that, we need to find the angle of the sector. So if you go old school and get your protractor out, we need that angle there, and we will get 70 degrees. Now, angles around a point add to 360, so that as a fraction is 70 out of 360. So we can say 70 over 360, which has a common factor of 10, so that's the same as 736. Of the people in Hadley are aged 0 to 19. So, on the whole, that is 736 of 25 41s. So, to calculate the final answer, we do 736 times 25 over 41, and let's see what we get. Okay, so we get 0.119. Now, how did it ask for it? So it only asked for what proportion, so that it would be fine. You could turn it into a percentage, which is 11.9%. Okay, number 12, we have this triangle RST, in which we are told RS and ST are two sides of a regular 12-sided polygon. So, if the polygon is regular, that means the sides are the same length. So, let's get that on there. Okay, RT is a diagonal of the polygon, so that means is it joins one corner to another corner. Our job is to work out the size of angle STR. So, angle STR is this chap here. Now, because those two sides are the same, and this is an isosceles triangle, so this angle down here is going to be the same too. Okay, so where do we start with this? Well, we need to be thinking in terms of polygons. So, what we can do is, if we extend this top line, then the angle between that dotted line and the next side of the shape is what we call an exterior angle. Now, exterior angles, so the sum of exteriors is always 360. Now, if you have a regular polygon, the exterior angles are all the same, and you have the same number of exterior angles as sides. So, the reason that we're finding an exterior angle is an exterior and an interior make up angles on a straight line. So if we find the exterior, we can find the interior, and then we can find the angle that we want. So, it's a 12-sided polygon, so one exterior is 360 divided by 12. Which is 30 degrees. Okay, so back to the diagram. We know then that this chap is 30 degrees. So, by angles on a straight line, this red angle has to be 150. So then by angles in a triangle, if we call these two angles x, and then we know that 2x and 150 is equal to 180. Take 150, and then 2x is 30, divide by 2, and we get x is 15 degrees. Cool. Okay, number 13, we have compound interest. So, at the beginning of 2009, Mr. Veal bought a company. The value of the company was £50,000. Each year, the value of the company increased by 2%. Part A wants us to calculate the value of the company at the beginning of 2017, giving our answer correct to the nearest £100. Okay, so in 2017, 8 years have passed. Okay, so we need to be thinking in terms of decimal multipliers. Now, 2% is 0.02. So to work out the value of the company, we do 50,000 times 1.02 to the power of 8. So let's see what we get. Okay, so we should get £58,582, 97p. So if we just say 58,583, because we're then rounding that to the nearest £100, so that's 58,600. Okay, then for part B we have compound interest with unknown interest rate. So, at the start of 2009, the value of a different company was £250,000. In 6 years' time, the value of this company is now £325,000. This is equivalent to an increase of X% each year. We want to find the value of X to 2 sig figs. Okay, so just as we did above, we would find the value of this company in 6 years. We would do 250,000 times some decimal multiplier to the power of 6, and that would give us £325,000. So we're going to call that decimal multiplier y. Can't call it x because x is the percentage rate. So what we can say is that £250,000 times y to the power of 6 is equal to £325,000. Now, if we can find the value of y, we can find the percentage. So, first thing we need to do is divide by 250,000, so we get y to the power of 6 is equal to 1.3. Now to get y, we take the 6th root, so we get y is the 6th root of 1.3. Now that's going to give us 1.0 446 blah blah blah. Now then, the part that increases is whatever's after the decimal point. So, this bit. So, to turn that into a percentage, we multiply it by 100. So, 0.0446 times 100 is 4.46. Now we want x is that to 2 sig figs, so x is 4.5. Okay, then for part B we have compound interest with unknown interest rate. So, at the start of 2009, the value of a different company was £250,000. In 6 years' time, the value of this company is now £325,000. This is equivalent to an increase of X% each year. we want to find the value of x to 2 sig figs. Okay, so just as we did above, we would find the value of this company in sixes. We would do 250,000 times some decimal multiplier to the power of 6, and that would give us £325,000. So we're going to call that decimal multiplier y. Can't call it x because x is the percentage rate. So what we can say is that £250,000 times y to the power of 6 is equal to £325,000. Now, if we can find the value of y, we can find the percentage. So, first thing we need to do is divide by 250,000, so we get y to the power of 6 is equal to 1.3. Now to get y, we take the 6th root, so we get y is the 6th root of 1.3. Now that's going to give us 1.0446, blah blah blah. Now then, the part that increases is whatever's after the decimal point. So, this bit. So, to turn that into a percentage, we multiply it by 100. So, 0.0446 times 100 is 4.46. Now we want x is that to 2 sig figs, so x is 4.5. Okay, number 14 we have inequalities and graph regions. So on the grid, shade the region that satisfies all of these inequalities. So we have y is greater than 1, x and y is less than 5, and y is greater than 2x. Okay, so the first thing we do to do these is think of each inequality as an equation, and we then draw the line of that equation. So let's do that. First of all, for y is greater than 1, so the line we're going to plot is y is equal to 1, so that is a horizontal line going across from 1 on the y-axis. So this is y equals 1. Now the region that we want is such that y is greater than 1. So that means the region that we want is somewhere above the green line. So we don't want this bit, we don't want this bit, and we don't want that bit. Okay, And for the second one, we need to plot the line x add y is equal to 5. Now that might not look very nice. What we can do is rearrange it and instead plot y equals 5 minus x. So all that you really need to plot that are 2 points. So when x is equal to 0, y would be 5. So that's that point there. And when y is equal to 0, we would get 5 minus x equals 0, add the x would be 5. So that would be that point there. So anywhere on that line, x add y is equal to 5. Anywhere above it, x and y is greater than 5. Anywhere below it, x and y is less than 5. So we want x and y to be less than 5, which means then we don't want this region or that region. Okay, we're getting there. So then finally, we want y is greater than 2x. So for that, we want the line y equals 2x. So hopefully you're right plotting that. Y is just 2 times the x coordinate. So that's the orange line we have here. Now we want y to be greater than 2x, so that means above the orange line, so we don't want that part there. And now we are left with the region that we want. Now don't forget to label it R. Cool. Okay, number 15 we have combinations and permutations. So Tracy is going to choose a main course and a dessert at a cafe. She can choose from 8 main courses and 7 desserts. Tracy says that to work out the number of different ways to choose a meal, you add 8 and 7. Is Tracy correct? You must give a reason for your answer. So Tracy is not correct. What you want to do is multiply 8 by 7 for each of the 8 main courses. You can choose 7 different desserts. So 8 times 7 would be 56. Okay, then for part B, 12 teams compete in a competition. Each team plays each other team exactly once. We want to work out the total number of games played. So, really there's 2 ways you could do this. Probably the easiest one is to, first of all, let's put all the teams in a table. So we're going to go team. And we're going to also put the number of games that they need to play along the bottom. So we're going to want 1, 2, 3. Okay, so we have all 12 teams in our table. Now what we're going to say is the number of games in the table is the number of teams to the right of that team. So, for example, team 1 has 11 teams to the right. So, if we imagine they play the teams in this order, then team 1 would play 2, 3, 4, all the way up to team 12. So, team 1 would have 11 games to play. Now, team 2 has already played team 1, so they just need to play the teams to the right of them, so they have 10 to the right. Team 3 has played 1 and 2, so they now have 9 to play. And this carries on. So, by the time we get up to team 12, they've already played everyone else, so they have 0 games to play. So, to work out the total number of games, we add all of the blue numbers together, and you should get 66. Okay, number 16, we want to solve x minus 2 all squared is equal to 3. Give your answers to 3 sig figs. So, if you were thinking about expanding the brackets, don't. This is completed square form of a quadratic. So, we're halfway there. So, what we need to do is get the x on its own. So, first of all, we need to undo the square, so we square root both sides. So we get x minus 2 is equal to, now you need to be very careful here, when you square root, you get 2 answers, positive and negative. So we get plus or minus root 3. So, then if we add 2, we get x is 2 plus or minus root 3. So, now we would need to use our calculators. So, to add root 3 is at 366, 3.73, and 2 minus root 3 is 0.2679, so to 3 sig figs, that's 0.268. Okay, number 17, we have histograms, so my stuff is down below. So the table gives information about the heights of 150 students. So we got height, h centimeters, frequency, and part A wants us on the grid to draw a histogram for this information. Okay, so they've given us a completely blank grid. So what I've done already, I've put the scale in along the bottom and labelled it height, frequency density up the side, which we don't yet know a scale for. So that is what we need to do for each interval. So, crash course in a histogram, you get bars with the interval width along the bottom and frequency density up the side. Now the area of each bar represents the frequency. So from that we can get that frequency equals width times frequency density. From that, if we divide by the width, frequency divided by width is frequency density. So we need to find that for each row. So for this top one, we are doing 15 divided by 10, which is 1.5. Next one, we are doing 30 divided by 5, that's 6. Next one, 51 divided by 5, that's 10.2. Next one is 36 divided by 5, which is 7.2. And then the last one, 18 divided by 15 is 6 over 5, 1.2. Okay, so the biggest frequency density that we need is 10.2. So, let's use every half square is 1. Okay, so then it's just a case of drawing in the bars with the frequency density as the height and the widths along the bottom. Okay, so your histogram should look like that. Cool. So then, for part B, we want to work out an estimate for the fraction of the students who have a height between 150 and 170 centimeters. Okay, so all that we need to do is work out the area of the bars between those two numbers. So 170 is here, and 150 is here. So, we already know that we're going to have these 3 bars in the middle. So that's all of the ones in those 3. And then what we need to work out is the area of this part of the bar. So that is going to be 5 times 1.2 which is 6. So we need to add these 3 together with 6. So 1351 is 81. 81 add 36 is 117. Add 6 is 123 out of all 150 students. Okay, number 18, pretty much the most pointless 1 marker I've ever seen. So at time t equals 0 hours, the tank is full of water. Water leaks out of the tank. At the end of every hour, there is 2% less water in the tank than at the start of the hour. The volume of water in litres in the tank at time t hours is Vt. Given that V0 is 2000, so that means the amount of water in the tank at the start, and Vt add 1 is equal to K times Vt. So that means the amount of water in the tank 1 hour later than now is K times the amount of water that's in there now. We want to write down the value of K. Okay, so it's pretty much compound interest or depreciation. So the amount of water is decreasing by 2% per hour, so 2% is 0.02. So K then is 1 minus 0.02, or 100% minus 2%, which gives us 0.98. Okay, number 19, so we're at that point now where really every question is very horrible. So a triangle has vertices P, Q and R. The coordinates of P are minus 3, minus 6, Q is 1, 4, R is 5, minus 2. M is the midpoint of PQ. N is the midpoint of QR. We want to prove that MN is parallel to PR. We must show each stage of our working. Okay, so if if MN and PR are parallel then they have the same gradient. Okay, so we can find the gradient of PR quite nicely. So now gradient is difference in y over difference in x. So P has a y coordinate of -6, R is -2. So we have -6 minus -2 over -3 -5. Now, -6 minus -2 is -6. Add 2, which is -4. And -3 -5 is -8. Now that gives us positive 1/2. So, the gradient of PR is 1/2. Okay, so what we now also need to do then is to get the gradient of MN. To do that, we need to find the coordinates of M and N. So we're told that M is the midpoint of PQ. So, midpoints are the mean coordinates of 2 points. So, so for the x coordinate, we're going to do -3 add 1 over 2. And for the y, -6 add 4 over 2. So, M has coordinates. Well, -3 add 1 is -2. Divide that by 2 is -1. And then -6 add 4 is -2. So again, -2 divided by 2 is -1. So the coordinates of M are -1, -1. Now we need to do that for N as well. So N is the midpoint of QR. So the x coordinate is 1 add 5 over 2. And the y coordinate is 4 add -2 over 2. So that's 4 minus 2 over 2. So, N is 3 and 1. So now we can find the gradient of those. So m is minus 1, 1. Minus 1 even, and n is 3, 1. So, the gradient of mn is, so let's do minus 1 over minus 1 minus 3. Now that is minus 2 over minus 4, which again gives us positive 1/2. So, PR and MN have the same gradient. So they are parallel. Okay, number 20. This is going to be fun. So, OAC is a sectoral circle, center radius 10 meters. We're told that BA is tangent to the circle at point A, and BC is tangent to the circle at point C. So, before we go any further, I'm going to point out what that tells us. So, in this lovely diagram then, those two tangents are the top left and top right sides of this quadrilateral. Now, by one of our circle theorems, when a tangent meets a circle, then the radius and the tangent meet at right angles. So, first of all, we know this angle is a right angle, and this angle is a right angle. Now, we also know that tangents coming out of the same point hitting the circle are the same length. So, this side length is equal to this side length. Okay, let's carry on. So, we want to, now we're told angle AOC is 120 degrees. Our job is to calculate the area of the shaded region, giving our answer to 3 sig figs. Okay. So, we have two main jobs. We need to work out the area of the overall shape, and we also need to work out the area of the sector and then subtract that from the whole shape. So, I'm going to do the sector first. So, the area of a circle is pi times the radius squared. So, if R is 10, we get then that the area is 100 pi meters squared. But we don't have the whole circle. So the angle tells us what fraction of the circle we have. So angles around a point add up to 360 degrees. We have 120 out of 360 degrees. So the sector is 123/60 of circle, which is 1/3. So 120 over 360 is equal to 1/3. So the area of the sector is 100 pi divided by 3. Meters squared. Okay, so that's that. Now, how are we going to work out the area of the whole ship? Well, the whole thing is symmetrical. So we can cut it right down the middle. And we also know if we do that, we get two congruent right-angled triangles. So what we need to do first is work out the angle up the top. So 90 add 90 add 90, 90 add 90 add 120 is 300 degrees. So then 360 minus 300 is 60 degrees. So if we cut this down the middle, we know the angle altogether is 60, or one of them is 30. So now we're in a right-angled triangle, which I'm going to make a sketch of. Okay, so I'm going to say the bottom length is 10. Now also by the symmetry, we know this angle down here would be 60. Now, as it goes, we didn't actually need this other angle, but when in Rome. So what we need to do is work out the height of this triangle. Base times height divided by 2 gives us the area. And to work out the height, we're going to use SOHCAHTOA. So the height then is the opposite, and the 10 is the adjacent. So we know tan 60 is equal to the opposite over 10. Therefore, the opposite is 10, 10, 60. So that is going to give us 17.32 meters. So, now that we know that, we can work out the area of the triangle. So we're doing 10 times 17.32 all divided by 2. So that's the same as 5 times 17.32. And that gives us 86.6 meters squared. Now that is half of the quadrilateral, because it's one of the triangles. So the quadrilateral is 2 times 86.6. Which is going to give us 173.2 meters squared. So the shaded area is that, so 173.2 minus 100 pi over 3. So let's see what we get. Okay, so I make that 68.48. So 68.48 meters squared. They wanted it though to 3 sig figs. So our final answer would be 68.5 meters squared. Okay, number 21, more probability. So there are 12 counters in a bag. There is an equal number of red, blue and yellow counters. So that means there's 4 of each counter. There are no other counters in the bag. 3 counters are taken at random from the bag. Part A, work out the probability of taking 3 red counters. Okay, so 22 marks. So when we pick our first counter, it's going to be, well, the probability would be 4 out of 12. Now when you're doing successive events like this, you multiply the probabilities together. If we've already picked 1 red counter, there's 1 less red and 1 less counter overall. So we multiply by 3/11. And then, again, if we've picked another red, there's now only 2, and there's now only 10 counters altogether. So, you could work that in your calculator. Simplifies to 1/3 times 3/11 times 1/5. So that's 1 times 3 times 1 on top. So that's 3. And on the bottom, 3 times 11 times 5 is 33 times 5. It's 165. That then has a common factor. Again, your calculator can do this. That has a common factor of 3, so it's 1/55. Okay, then for part B, those 3 counters are put back into the bag. Some more counters are added to the bag. There are still the same number of red, yellow, and blue. There are still no other colours in the bag. 3 counters are again taken at random from the bag. Part B asks, is it now more likely, equally likely, or less likely that all 3 are red? So, the easiest way to do this is to add an amount of counters to the bag. So, let's say we add 1 counter each to the bag. So, there are now 5 red and 15 counters overall. So the probability is now 5/15 times 4/14 times 3/13. So this time I'm just going to work that out as a decimal, and we will get, well, as a fraction, it's 2/91. Now, as a decimal, that is 0.021. Now, if we also turn our probability above into a decimal, so 1/55 is 0.018, blah blah blah. So 1/55 was equal to 0.018. So 0.021 is more likely, so it's more likely. Okay, number 22 is functions and simultaneous equations, all in the same question. So the functions f and g are such that f of x is 5x add 3, and g of x is ax add b, where a and b are constants. We are told that g of 3 is 20 and f inverse of 33 is equal to g of 1. We want to find the values of a and b. Okay, so this might seem very daunting. Where can we start? Just process the information. So we know that g of 3 is 20. Now, g of 3 just means we're substituting x equals 3 into the g function. So we would get a times 3 add b, or 3a add b. Now we're also told g of 3 is 20, so that means 3a add b is 20. So that is all we can do there at the moment. But what that's got us is an equation in terms of a and b. So let's now see what we can do with the other stuff. So we are told f inverse of 33 is equal to g of 1. So let's find f inverse. Again, there's separate videos on all of this stuff in the functions playlist, which is down below. So to find f inverse, we start with f of x is 5x add 3. Now, I'm just going to call f of x f. So I'm just going to say f is 5x add 3. Now we want to make x the subject. So we're going to subtract 3. So f minus 3 is 5x. Divide by 5, we get f minus 3 all over 5 is equal to x. And now to get the inverse f and x now swap places. So we get x minus 3 over 5 is the inverse f function. So from that, we can now get then that f inverse of 33 is 33 minus 3 all over 5, which is 30 over 5, which is 6. Now, we can also work out g of 1. So g of 1 is just going to be a add b. Now, remember that we were told that f inverse of 33 was equal to g of 1. So we now know both of those things. So we now know then that 6 equals a add b. Or a add b is equal to 6. So we're now done with functions. Now it's simultaneous equations. So we now know that 3a add b is 20. And a add b is 6. So, if we call the equations 1 and 2, both of them have a single b, so we can get rid of that by doing 1 minus 2. So 3a minus a is 2a. b minus b goes away. 20 minus 6 is 14. From that, we can then get a is 7, which means then that if a add b is 6, b has to be minus 1. Cool. Okay then, number 23. So the final question, and really it belongs on an A-level paper, but there we go. So, well done to anyone that's still here. Probably as tired of this paper as I am. So, S is a geometric sequence. Geometric sequences are when you multiply by the same amount to get from term to term. Arithmetic are when you add the same amount. So we are told, or given that root x minus 1, 1, and root x add 1 are the first three terms of S. Find the value of x. You must show all of your working. Okay, so this means then that to get from root x minus 1 to 1 to root x add 1. Now we usually call this a common ratio, and we usually call it R. So we're going to say we are timesing by R. Now from this, then we can say that root x minus 1 R is equal to 1. So just root x minus 1 times R is equal to 1. Which isn't much use. We can also then though say that 1 times 1 times R is root x add 1. Now then that means that R is root x add 1. Because we had 1 times R. So now the above becomes useful. We now know that root x minus 1 times root x add 1 is equal to 1. So where that's come from is that line, because we now know that R is root x add 1. Okay, now if we expand these brackets, it's quite nice. It's a difference of 2 squares, so we just get root x times root x, which is x. We get minus root x, we get add root x, so they cancel each other out. And then we get minus 1 times 1 gives us minus 1. So x minus 1 is equal to 1, therefore x is equal to 2. Okay, so then part B wants us to show that the fifth term of S is 7 add 5 root 2. So now that we know what x is, we know the first three are root 2 minus 1, 1, root 2 add 1. I always get phone calls when I'm doing this. Okay, so then we know the fourth term. And at this point you can absolutely just do this on your calculator, but for those of you that don't like using them like me, I'm going to do it with that. So the fourth term is root 2 add 1 times root 2 add 1. Now, if we expand that out, then we are going to get root 2 times root 2, which is 2, add 1 times 1, which is 1, so that gives us 3, and then we're going to get 1 times root 2 twice, so that's 2 root 2. So then the fifth term is 3 add 2 root 2 times root 2 add 1. Okay, so 3 times root 2 gives us 3 root 2. 3 times 1 gives us 3. Now, 2 root 2 times root 2 gives us 2 root 2 root 2. Root 2 root 2 is 2. So, 2 root 2 root 2 is 2 times 2, which is 4. And then we get 2 root 2 times 1, which is 2 root 2. So, altogether, we have now got 3 add 4, which is 7, and 3 root 2 add 2 root 2, which is 5 root 2. Which is what we wanted to show. Okay guys, on that then, the paper is done. Hope you found it useful. Don't forget, down below you can get a playlist with every Edexcel past paper walkthrough. Lots of other useful stuff down there too. Make sure you take a look. Don't forget, give us a thumbs up, get subscribed, buy a t-shirt if you're awesome. Take it easy, take care.